Okay, let's make a start. My name is Panos. I'm the program manager for the custom speech service, and we're here to talk to you about speech. We'll have a number of things to show you today. That's why the commotion on stage just before the start. The agenda to follow will be, we will discuss speech offerings, a number of speech products. You heard about some of them on this morning's keynote. Then we will focus a little bit on the custom speech service. We will make some announcements about some new features coming up for some of the products. And then we'll have a number of demos. My colleagues, Ivo and Kuram, will help me present. So let me get right to it. So we use speech a lot, as you know, in Microsoft in some of the products that you use. So you know about Cortana, obviously, and the ability to voice activate certain actions, as well as the ability to convert text to speech. You know about Skype and the translation feature. And you know about the voice activation, the voice navigation also of Xbox. The technologies behind these are usually the ability to convert audio into text, speech to text, we call it, and the ability to synthesize audio from a piece of text, so text to speech, and to a lesser extent, the ability to recognize the profile of a particular speaker given a piece of audio. Now, we deliver the same technologies to you that we actually use internally through a library that we call Cognitive Services. Now, Cognitive Services is a bigger library. It encapsulates vision, APIs for vision, for speech, for image processing, and so on and so forth. But the ones I want to concentrate on today are effectively Speech API, also known as Big Speech API, Custom Speech Service, the one I work on, and the Speaker Recognition API. So let's see each one of them in turn. Now, let's say if you want to build an application that you activate using your voice, right? You trigger some actions using your voice. So the easiest and the quickest thing to do for something like this would be to go and use the Big Speech API. What it is that it uses the Cortana models that has deployed, pre-deployed in the cloud. And what you do is you get an API, an SDK. You download an SDK through which you can actually use these models, upload audio to get back transcription, or upload text to get back speech. It's simple as that. Within 10, 15 minutes, you can be up and running. You can add voice and speech recognition ability into your application. As I said, the models are pre-deployed for you. We have the SDK supports both REST calls on the models, as well as WebSocket calls for continuous transcription. And there is support for a very large number of languages for both speech-to-text and text-to-speech. I'm going to go, so you can be up and running, as I said, very, very quickly. So the actual SDK, I want to show you a bit of code, how a call to one of these models would look like. As you can see here on, the only thing you need to do once you download the SDK is basically set up, instantiate a client. On the example here, I'm using the factory method to instantiate a microphone client. And the parameters I pass, as you can see from the code, are the mode of the audio. So all I'm saying there is I'm going to use short phrase. What this means is I'm going to be uploading short pieces of audio up to 15 seconds long. I pass the locale as well. And then I also pass my subscription key, which I get from the Cognitive Services. There is a bunch of events that I can subscribe to. The one to draw your attention is the partial results. You can use this to actually get partial results. As you upload the audio in real time, you get results of the transcription, and obviously final results. But it is simple as that. So you can download, you can use the samples, you can use the samples to actually create your own customization of this, and you're good to go within minutes. where custom speech service becomes useful is on the following scenario. Let's imagine that your application is going to be used in a noisy environment. Let's say, for example, your users are going to be using the application within the car, or they're going to be using the application in something like an airport. There is a lot of ambient noise that you need to be able to deal with. Or let's say, imagine a scenario where the language of the application is very specific. Let's say this is an application about chemistry or finance or something like this. Or it uses custom vocabulary, new vocabulary, like acronyms or product names, and so on and so forth. What custom speech service allows you to do is use these baseline models and customize them for your application, specifically for your application. You need to bring your own data in order to customize that model. But once you customize the model, then you can deploy your model the same way you have the models pre-deployed, and you can be up and running and using those models using the same SDK. I want to go into a demo very quickly, just to show you what I'm talking about. Okay, there seems to be a problem with the machine. Okay, there we are. Okay. Okay, so this is an application I built in order to demonstrate the custom speech service. So it basically simulates an airport kiosk, an imaginary airport kiosk, where travelers go to ask information about either flights or services within the airport. So you can imagine when a traveler goes to a kiosk within an airport, it will actually be very noisy. So this is what this demo is trying to simulate. So I have a list of pre-recorded utterances. So I will play one of you just to see how this sounds like.
What sort of aircraft serves Flight 459?
Did you hear that? Okay. So you see, it's an utterance for a flight information within the airport, so you can hear the background noise. So I'm going to be sending that to a baseline model to see what it does with it, and I'm going to be sending the same utterance into a custom model that I built. You'll be seeing the results.
Show me all flights from Pittsburgh to Boston, both direct and connecting, that depart Pittsburgh after 7 p.m.
So you see the intermediate results coming up, and now you see the final result. So on the left, you see the baseline model. It's actually doing okay. It's not doing great, but it got most of it correctly. On the right side, it's the result of the model that I actually customized with a few hours of acoustic data from airport data. So it's actually doing quite well. You heard the utterance, you can see this is actually pretty accurate. So this is a point of using customization. You can bring your own data, as I did, airport-related data, customize the model, and it actually gives me quite accurate results despite the background noise that you actually heard. For this particular demo, I also had the language data, so like airport names, airline names, and so on and so forth. So it is able to deal with that kind of stuff as well. Now, going back to the presentation. So how do we adapt a model like this? It's actually, if you do it on the custom speech service, actually quite easy. So as I said, you need to bring your own data, but you upload the data to our portal, and I'll show you how this is done. Once you upload the data, and then you do the adaptation. You can do it more than once. You can adapt more than one models. You can evaluate those models to see how accurately they perform against some test data that you may have. And then eventually, when you're happy with the results, you deploy the model on the cloud, and you get some URIs to which you can go and make calls. So, so with that, I want to go into the custom speech service portal, just to show you what it looks like. And I actually want to show you the insides of the airport kiosk demo that you saw. I'm going to log in with my account. So this is the initial screen that you see. There is information in here once you log in with a nice guide, gives you details about what is acoustic adaptation, language adaptation, so on and so forth. And through this menu, the custom speech menu, you can do the steps that I showed you on the slide. So basically, you go to data adaptation, you can upload your different data sets. As you see here, I have a data set for the airport acoustic data. So these are the acoustic utterances that I uploaded, that I used to adapt the model that I used on the airport kiosk demo. And my language data down here. If you click on the details, you can see, for example, some useful stuff, such as the number of utterances that were added as part of the language model, and so on and so forth. Once your data is there, and you're happy with it, then you go to intern, to the acoustic models, and you create those. Obviously, I have an acoustic model created because I was using it for the demo. You can do the same. You know, all you need to do is actually straightforward. You give it a name, you give it a description, you pick up a baseline, be it conversational or certain dictation. You have some decision to make here whether you want to transcribe scenarios like phone calls, and therefore using conversational model, or command and control type scenarios where you would use the search and dictation baseline model. But once you select that, then you point to your acoustic data, such as the airport acoustic data that I imported earlier, and then you create your model. There is another feature here that we use quite a lot. We call it accuracy testing. You can point at the same time to some test data that you may have. So during the creation process of the model, you can actually test the model itself. So when the process completes, you get some information about how accurate the model is against the test data. And the same process goes on with the language data. I'm not going to show you the same menu, but basically, you can see I have a couple of models here. You do create new, and you go through the same steps, more or less. You define a baseline model, an alias, your language data, and you do the same thing. So now that you have your acoustic model and your language model, you can decide the following. You can decide if you want to do more acoustic tests. I don't have any pre-done, but effectively, if you have more test data, you can run them against the models you have created, and you can see some results. You can store these results. These are automatically stored in your account. You can use them to compare with previous results, and you can make informed decisions on which model you want to put into production. But let's say you want to put a model into production, you just go into deployments, and you create a new deployment. I have one created, obviously, because I'm using it on the demo, but I want to show you the screen. So you give your deployment a name, you give the description. Again, you select the baseline. Based on this information, we can see which model you have created. I have created a couple, and then you select what you want to actually go and deploy. You give it your subscription key, and you do deploy. Simple as that. I'm going to show you the details of the deployment. So this is the deployment for the airport kiosk model. If you look at the details, you can see when the model was created. But more importantly, you can see the 3 URIs that we actually expose for the model that we deploy. So you can see the HTTP for doing REST calls, and the WebSockets for short phrase mode, a few seconds of audio, or the long dictation, which I think goes up to 2 minutes. So on the demo, as I said in the beginning, I was using the Speech Client SDK. It's the same SDK for Speech API and Custom Speech Service. And in terms of code, all I did was I just copy-pasted the UI that I wanted to call. And then I went back into the code I showed you previously. And the only information I had to touch in there was just basically the model URI information. Currently, I also need to touch the new subscription key. We have different subscription keys between Speech API and custom speech service. But as I said, we have converged on the SDK, and we're going to be converging on subscription as well and all that stuff. The rest of the code is actually the same. You subscribe to the same you register to the same events, and you're actually good to go. The difference between using the Speech API and the custom speech service is that I brought my own data in order to customize the baseline models. So what we have said so far is we had a look on the Speech API. We discussed the Speech API a little bit, and we said that it uses baseline models that you can easily access through the client SDK that we provide. And we saw the custom speech service, where you bring your own data, you customize the model, you put it on the cloud, and you access it through the same SDK. Now, some information, some new information. So there was a lot of feedback for you requesting support for intermediate results for the Bing Speech API. And we actually provide that now. There's a WebSocket protocol out. It's actually public. There's a reference implementation in JavaScript, but you can use this spec yourselves to build your own implementation in the language of your choice. There's also support on Speech API for conversational models. So these are the same models that Skype is using. So you can access those using the same SDK. We lifted the limitation of 2 minutes for continuous audio streaming to 10. So we make it more easy for you now to transcribe scenarios like phone calls. And there has been recently, last week, a bunch of new languages for supporting text-to-speech and a number of support for more locales and more voice phones. For the custom speech service, we are bringing out German next week, support for German. So we're going to be supporting, we are supporting English and Chinese. Now we're going to be supporting German. We're going to bring out Spanish, actually soon after that. We have a new feature, actually very important, called custom pronunciation. And this is something that we heard from you a number of times. Many people said that they wanted to customize how particular terms, new vocabulary is pronounced, such as acronyms, for example. So we have a feature that's coming out in relation to that. So it's very easy to define. You just basically upload, along with your language data, a text file that combines the display form of the new vocabulary along with the spoken form in pairs. You can see the example here of the CPO, BB8, and so on and so forth. So this is very easy for you to go and define. And on the documentation, actually, when this feature comes out, there will be a lot of examples, so it will be easy for you to follow and define your own spoken form for your own vocabulary, your own acronyms. We also decoupled the evaluation of the models that you create from the creation process. I said earlier, if you remember on the portal, you can test the model while it is being created. Now the actual testing process has been decoupled from the creation process. You can make as many tests as you want against the model that you created, and we keep the results, so you can see, you can compare, you can make more informed decisions. And you have also been asking for simplification on the pricing for the custom speech service. So we have taken this on board. There will be new pricing coming up. I cannot give numbers out now, but will be out very, very soon. But one of the things to know, for those of you that have been using custom speech service, is that you have been asking for more freedom when it comes to adapting models. So we have lifted quite a lot of the constraints for that. So basically, we give you a lot more freedom to go and experiment with the whole model creation process. You have also said that you wanted to be able to deploy more models per paying tier. Currently, for each pricing tier, you can deploy just one model. We are going to be giving you the freedom to deploy basically as many models as you like. And you also asked for freedom when it comes to defining the scaling of the model. And by scaling, I mean how many audio requests you can concurrently upload. So this is something you will be able to control. So as soon as you create a deployment, as I showed you on the portal, you will be able to define how many concurrent audio streams you envisage being sent to that endpoint. So this is coming up soon. So with that in mind, let's go and have a look on a couple of demos. Can I invite on the stage first my colleague Ivo? So he's going to show you how these technologies have been used to enhance PowerPoint and create captions on PowerPoint. So,
thank you, Panos. So you probably saw this morning during Harry's keynote a very interesting demo about the translator, where Yina was talking on PowerPoint in Spanish, and then Harry was talking Chinese on the phone. I want to talk a bit more about the technology behind that. I want to show you also how custom speech service is powering that experience and how much value we gain by using custom models. So with the translator plugin that Harry showed in the morning, so you can have live transcriptions and translations, so you can pick either the original language of the speaker or any of the other supported languages, display them on screen, and also connect from your mobile phone, as Harry has shown. So we support iOS, Android, Windows, web browsers, and you can join as a participant and make questions on your own language. Basically, you can speak as Harry did in Chinese, and then the other participants are going to see the translation in their own languages. The part I'm going to show now and focus now is the fact that we do use the slide contents to customize the presentation. So basically, technical vocabulary, new terms that you have here in the slide deck are going to be leveraged by the translator plugin, and then you're going to have way more accurate recognition results. On the back end, we are also adding an experience where the service learns from the speaker. So basically, the more you use the service, with the fullness of time, the better the accuracy results will be for your voice. So let me show you a demo. So basically, I have here what I call the impossible slide. It's meant to be a funny demo. So that slide has statements about different topics. So I'm talking about biology, about computer science, business, or geography. And I'm going to now do a side-by-side comparison of, let me just unlock my machine. A side-by-side comparison of a model which has been customized with the slide contents versus a model which has not been customized, which goes against the baseline. So let me switch this. So as you see, the translator was running all the time, so everything that was being said was being captured here. But now I wanna focus on exactly the contents of this slide. So imagine I'm doing now a class on biology, and honestly I have no idea what I'm gonna say, but those words seem difficult. So the biomimetic approach of the Fujianese frog is amazing. So you can see on the upper box the non-customized version, what would be a base model. You can see on the lower caption and the last utterance there, the result of customization. And all we used to customize that model was just the contents of this slide, nothing else. Just the contents of this slide on top of the base model, using custom speech services, and all automatically. I'm going to show next slide a bit of what's under the hood. So the user doesn't have to do anything, just click a button. So it's all done using our service. So let me try another sentence here. So now I'm giving a class on computer science, full of technical terms. You're very used to that, giving presentations about technical stuff. So LSTM is also important for ASR. Actually, you saw that the one below got it. The one above, I'm not sure if I was muted or if this thing just didn't. Hello? Yeah, okay. So I will say again. Probably I was muted on the one above. So LSTM is also important for ASR. So, and if you try something without customization, and you're talking about Azure and all those acronyms that we at Microsoft love to create, you're going to see it's not going to go very well unless you do customization. Okay, just another two because this is becoming funny, and then I'm going to show you a bit more about the architecture. Make sure I unmute. So let's say now I'm giving a presentation, I'm an executive, and I'm talking to my employees about a new division that I have in my company. So the AI plus R division is a brand new group. So you can see again, on top, it got almost right. And on below, it got exactly what I was expecting. And by the way, I don't need to read exactly how the sentence looks like. I'm just doing this here. We can try in different orders. The way we build language models is based on adding the vocabulary and also the probabilities of words coming before and after each other. So it's not because in the slide it's written like that, you have to read like that. Just the fact that the term is there, the system's going to learn, and then it's going to do the correct recognition. So let me try a last one. Now it's a class about geography, or I'm talking about tourist attractions. And there is this nice little village in Britain called Plougastel. Plougastel. I can't get it right. Yeah. So when I said the way the system was expecting, I don't know. I'm not a native speaker on this one. You can see that the one below got it. So Plougastel is a nice little village in Britain. You can get the idea, right? Good. So let me switch back to the slides. Yeah. So basically, how have we done that? I mean, this is a product we are shipping now, right? So you saw the announcement. Behind the scenes, basically, we are just using technology which is available to all of you today in cognitive services. There is, of course, a service behind it. There is a code to make that work. But from the API perspective, from the real complex problems that we're trying to solve, it's all available in cognitive services. So we're using a combination of custom speech service, translator APIs, and we're going to add very soon speaker identification. So basically, the ability to differentiate speakers in a talk. How it works, so basically we extract the text, the slide contents from PowerPoint, directly from PowerPoint, so the plugin knows how to do that. The plugin sends the textual data to our service, to Custom Speech Service API. We create a language model out of that, like Pano showed on the portal. We do it programmatically. We generate a custom speech recognition endpoint, and then when you're doing the presentation, the PowerPoint client is just calling that endpoint, sending audio in, the audio from my mic here, getting text out, and then presenting that in the UI. There are some additional steps that we do on the way, like, for example, capitalization, punctuation, but our service also offers that for you. So you get the whole end-to-end. And then if you are on the translator experience, the translator service is talking to the custom speech service and getting the transcriptions in the original language, for example, in English, and then doing the translation to the target languages, and then you can even connect with a mobile phone. So that's what I had to present now. Panos?
Thank you, Ivo. Okay. Next, I would like to talk about the speaker recognition API because we haven't really touched on that. If we go back to the application that we were talking about in the beginning. Let's say, for example, your users, you want to recognize who is actually talking to the app. The way to do this is by using the speaker recognition API. What it allows you to do is create with short fragments of audio profiles on somebody's voice or voice imprint. It stores those in the cloud, and then when you get an incoming piece of audio, you can actually match or try to match it against the profiles you already have. This is quite useful in a number of enterprise scenarios. One that we hear very often is the call center scenario, for example. On the examples we show you, transcription came from a single voice. On the call center scenarios, for example, you have the agent talking to a customer. So when you produce transcription out of that, it's actually quite useful to know who said what. Even if you don't have the profile of the customer, which is likely you're not going to have, you can still recognize the profile of the voice of the agent and then deduce who the customer actually is. So you can get much more accurate transcriptions out of that. The second scenario, enterprise scenario, which is useful and we hear a lot, is the meeting scenario, where you have a number of people on a round table, and then you want to take notes. Obviously, by taking notes, you want to know who said what and who is taking what action. So by using this technology, transcribing using speaker recognition, you are able to do this. So on the next demo you're going to see, we will try to demonstrate speaker recognition for you. And at the same time, you will be able to see how these technologies are being integrated or can be easily connected with the rest of the stuff, with the rest of the APIs on the cognitive services library, such as natural language processing that we show you here, but you can do other stuff like vision, imaging, and so on and so forth. So I would like to invite on stage my colleague Khurram. He will take over and he will show you. So he will show you a bunch of demos relating to what I just said. Khurram.
Thank you. Just going to do a quick hot swap of laptops. You don't need this one, right?
Yeah.
Okay. So you saw Ivo give a very compelling demo earlier where speech recognition and transcription from audio to text was being used to create effectively a new mechanism for people to consume content in a talk. So if they were not able to listen to the audio, they'd be able to read the text for the presentation. If they were not a native speaker for the language in which the talk was being given, they'd be able to consume the talk still in their own language. So that's an example of where speech recognition and converting from audio to text is kind of the end goal. There's a whole class of scenarios where speech recognition is really means to an end. It's not the ultimate goal. One such example is a scenario where you take the audio from what the user is saying, and once you've converted it to text, the next step is trying to understand what does that text really mean. So what was the user's intent? What are they talking about? What do they want to do operations on? And once you've got an understanding of what it is the user said, you want to take an action on that understanding. You want to process their command based on your own business logic. So for example, if the user's utterance is to find the nearest restaurants, you want to convert that audio to text. You want to understand that the intent is to locate restaurants. You probably want to understand that the current location is Seattle, Washington. Based on their coordinates, you want to do a local search. And that's your own business logic that you're identifying the local restaurants. And then you want to get that information back to the user. Now, if the user started by speaking, it's probably natural for you to interact back with the user using speech. So then at that point, you have to convert text back to speech, so text-to-speech service. So the reason I bring this up is in many scenarios, that involve speech recognition, there are a whole host of cognitive services that work end-to-end together to deliver the whole experience. One specific example that really showcases this is bots. So if you're building a bot or an intelligent agent and you want the user to be able to interact with this bot and understand what the user is saying, you use a whole host of cognitive services, and I'll give a quick demo of that. Before we jump into that, quick show of hands of how many of you are familiar with or have built a bot before using the bot framework. Okay, a fair number. So just for the rest of you, I'm going to give you a very quick overview. So the bot framework is essentially a framework that you can use to build a conversational agent. It's able to converse with the users across multiple different channels. You could connect it to Skype, you could connect it to Facebook, to Cortana, through your own application, in many different ways. So it's a platform for you to build on. And the reason it's powerful is it makes it easy for you to connect with the rest of the cognitive services. So for example, speech recognition, language understanding, and so on. So we're going to take a look at one such example by switching over to this laptop. Where's the switch? Input. Okay. So here's an example application that I've built. I've connected it up to my bot. This is a trivia bot. It supports users playing trivia games. The bot plays the role of the game show host, and the user is the contestant. That's kind of the UI that we mocked up there. And let's try to have a conversation with this bot. Let's play trivia.
Welcome to Trivia. To stop playing, you can say, cancel, or, I'm done playing, at any time. Now, let's get started. Here's your first question. What country is the second largest in the world by area?
China.
Not quite.
what I get for
The
doing
correct
this live.
answer was Canada. Here's one more. What is the capital of British Columbia, Canada?
Victoria.
Correct. All right, here's the next one. What was the cause of death for Freddie Mercury?
Yeah, let's switch back to the geography category.
You've switched to the category geography. How many countries does Spain have a land border with?
2.
Sorry, the correct answer was 5.
Maybe I picked the wrong category.
All right, here's the next one. Which of the following European languages is classified as a language isolate?
The first one?
I think you said Galician. Is that your final answer?
Yes.
Sorry, the correct answer was Basque. All right, here's the next one. Which of these is the name of the largest city in the U.S. state Tennessee?
I was going to say I'm going to quit while I'm ahead, but clearly I'm not, so I'm just going to quit anyway. So this is an example of a user interacting with the bot. Most of the logic here is actually in the service. This is just a front-end UI that the application is showing. We're going to show one additional demo here before I talk about how this is built. So I'm going to try doing speaker ID with the same scenario. We're just going to leverage the existing UI, and we're going to have the bot decide whether it was me or Panos that was answering the question. And we'll try to keep track, and I'll try not to go in the negative this time.
That's right.
I'd like to play trivia.
Welcome to Trivia. To stop playing, you can say, cancel, or, I'm done playing, at any time. Now, let's get started. Here's your first question. According to Greek mythology, Atlas was an Olympian god.
True.
Not quite. The correct answer
That is
was
false.
false.
Only if we had a
Here's
Greek on
one
stage.
more. In the game Overwatch, which quote does the hero McCree not say upon using his flashbang ability?
The fourth one.
I think you said you done. Is that your final answer?
Yes.
Congrats, you got it right. Okay, next question. In the play Oedipus Rex, Oedipus kills his father due to jealousy in loving his mother.
True.
Yeah.
Oh, actually, no, that's not right.
Not quite. The correct answer was false. All right, here's the next one. The planet Mars has 2 moons orbiting it.
False. Oh, it took too long. Oh, sorry, yeah. You gotta-
Sorry, the correct answer was true. Okay, next question. The Battle of Hastings was fought in which year?
The fourth one?
Sorry, the correct answer was 1066. Here's one more. Who is the main character in the show Burn Notice?
Michael Weston.
It's not listening. Try.
Michael Weston.
Sorry.
Michael Weston.
Michael Weston.
Congrats, you got it right. Here's one more. FLAC stands for Free Lossless Audio Condenser.
Yeah, I don't think either of us are going to get that one right. We're going to.
Well, we're 50-50. So, false.
That's right, the answer is false.
So we're going to pause
Okay,
and move on.
next
in the interest of time to
question.
the next
In
one.
Left 4 Dead,
Enough.
Yeah.
So the example that you saw in this case was a UWP application. I'm going to quickly show you the code involved here. Whoa, make that a little bit smaller. Is that legible? Okay. This is just a UWP application. There's a NuGet package that's available. It's called Microsoft Bot Client. It lets you talk to any bot. And that's what I'm using to connect with from this application. And in this case, you can see it takes a couple of options for what would you like to do in terms of speech synthesis and speech recognition. And I'm using Cognitive Services speech recognition for my audio to text conversion. And the rest of this application is really just UI binding to the data that's coming back from my bots. There's no logic here. So what that really means is because my bot actually lives in the service and is using all the cognitive services, it's actually the same experience is available in the browser window as well. So this is the same experience in the browser. Let's play trivia.
Welcome to Trivia. To stop playing, you can say, cancel.
So you see here that I can jump right in and tap on options. I can type back if I wanted to, and so forth. The reason I show this here is to point out 2 things. One is that cognitive services are what's really backing this experience, so it's portable, it's available everywhere. It does speech recognition, whether it's in your client application, whether it's an IoT device, whether it's a server farm, whether it's a web-based application. This could be a JavaScript UWP application, or it could be just in the browser itself. And as Panos mentioned earlier, one of the strong points of feedback that we've received from the community is the prior lack of support for doing live speech recognition with intermediate results flowing back. So as you saw here, I was able to press the microphone button and say, let's play trivia, and the words incrementally came back. And this is actually using the new JavaScript reference SDK that Panos mentioned is available earlier. I'm going to show that really quickly here. So we have documentation available for the WebSocket protocol, so you can go write your own client if you wish. But we also have a reference implementation available in JavaScript. So you're able to get started right after this session, if you'd like, by taking this SDK and doing, I see some nods here, for doing some speech recognition. So I'll give you a very quick overview of the SDK. You start by setting up a configuration. Is that better? We'll do this. So you, of course, start with your cognitive speech subscription. You pick your language, and then you simply start recognition. And once you start recognition, you get a whole host of events as activity is occurring. So as we detect that a phrase has started, as we detect that we started getting audio, as we get an intermediate recognition result, all of that information is being sent back to you as WebSocket messages for you to consume immediately. So you can update your UI live with what we're recognizing, and you can automatically endpoint the audio. So in this example, when I pressed the microphone button and I said, let's play trivia, I didn't do anything else to endpoint the audio there. The audio just went to the service. Service decided what was the best time to stop listening for further audio. So it's able to do that based on the amount of silence that's been after the last utterance, as well as the utterance itself. So all of that logic you no longer need to build into your end client, and the user can effectively operate this completely hands-off. So this is a quick overview. The sample is available, the reference implementation is available on GitHub. It's called the speech-to-text WebSockets JavaScript sample. And we'll have a pointer to this as well as the documentation available after the talk as well. Now, we've started talking about bots. As I mentioned, it's a very common scenario to do speech recognition and then also language understanding together for bot scenarios. You can imagine that if you want to extract the intent behind an utterance, you better get the audio to text conversion right. Otherwise, you have some loss of information that you could just never recover from. And in this example that I showed, we made it very easy, if you're building a bot, to leverage LUIS for language understanding and then have that work seamlessly with cognitive speech. So I'm going to show you very quickly what that involves. So if you're familiar with the Bot Framework Developer Portal, this is where you go. You've got your registry of bots. I've got a whole host of bots. If you click on one of them, you can see the settings associated with that bot. In here, we've simply just added a section where you can go and associate that bot with the associated LUIS model. That means that when you have any client, whether it's the web-based or your application, that tries to do speech recognition associated with that bot, we automatically use the context that's available in that LUIS model for speech recognition, so that your intents and your entities that are defined in your LUIS model, they're much more likely to be recognized correctly through speech, similar to what Ivo showed. Now, this gets you started with a basic custom model, but of course, you get the full ability to go and build a custom speech service model where you can customize the acoustic model, the language model, and also the pronunciations as well. And then, when you're building your own client, you have the option for which endpoint you're hitting and what solution you're using for speech. So you have the full flexibility for getting custom speech as well as Bing speech, and it's personalized for your experience. Let's take a look. I think that was everything that I had to cover today. I will give pointers to those of you that are here and interested in building bots and applications. If you're interested in taking a bot and connecting it with an application or within the web-based experience, please check out the Bot Conversations for Apps talk. You can search for it on Channel 9. It should be available. And for those of you attending in person, you can also come find me and some of the coworkers upstairs in the hub from 3:30 to 5 tomorrow. And we'd love to show you some more demos in much more detail than this, and also talk to you about your specific scenario and get some feedback from you. All right, thank you.
Thank you, Khurram. Okay. Okay, so Khurram showed you how easy it is to hook up the technologies we show you on speech with all the cognitive services to build more elaborate demos. Ivo showed you how he was using the technologies to build very nice features on PowerPoint. So the things I want you to remember is that these technologies are there for you. They're very easy to use. As I said, you can get yourself set up your application with speech within minutes if you use Speech API, and then it just takes a little bit longer as long as you have the data to create a custom model and go and use it. The models we create are models you can put into production. They actually do scale up. They can accept quite a large number of concurrent audio streams. And the final point I want to make is that we do quite a lot of research within the company in speech, and we do try to make sure that innovations and new things become available to you as quickly as we actually develop them. With that, I would like now to go into question time. I'm going to put some URIs up there for you to use. Before we take questions, I want to say that a few of us from the related products are actually here, and we plan to stay around for a little while longer. So if you want to come and talk to us and discuss your scenarios in a more informal setting, please do. If you do have any questions, please fire away. Please ask now if you want to come on stage. Questions? Anyone? Can you come to the mic so they can hear? Did you hear the question? No.
Quick question. So you showed that you can, you must train in voice. How many samples do you need?
Well, we say that for acoustics, if you start with like 2 hours of acoustic data,
2 hours.
It's a good enough sample. So I've done quite a lot of adaptations. 2 hours is good enough to make sense. So you should be able to see improvement over the baseline with 2 hours of acoustic. And then you can decide, right? Depending on the domain. But then you can decide if you need more.
And do you need to provide a transcript of the
You need transcripts, yes, for the adaptation data because we use that as labels, effectively. Yes.
So my question is there any plan to support like a different type of like a codec, audio codec? For example, like a AMR or a Speak?
Yeah, we are under internal discussions to increase the support. We cannot make any announcements now, but yes. Yes, we want to support other formats for sure.
Thank you. Anybody else? Yeah.
A question on the more exotic languages. So currently Lewis supports 10 languages, but there are many more out there. How aggressive are you guys in adding new languages?
So we're going to become a bit more aggressive now. So we went public beta in February with custom speech service. Actually, Bing Speech API supports a decent number, actually a large number of languages. We don't support Greek, no. So we support English, Chinese, German from next week, and then we're going to do Spanish, and then there is some other language in the pipeline. Is there anything in particular?
Well, this was primarily toward Lewis that currently supports 10 languages.
Yeah. We're going to be converging we're going to be converging languages within the Congress services, yeah.
Language is certainly one of the top things that is on our priority list. One of the things that we look at is making sure that we test the experiences out in certain locales and languages, and those work well. And then we have learnings from that. There are some language-specific things, and it's a process that we learn from. We do have some other sessions and some experts in the Lewis space that, if you hang around, I can point you to them in the hub specifically. And they can answer specifically about the roadmap, but just from having experience in language understanding space with the Lewis team, it is an important category that we're looking at right now.
I would appreciate that if you could.
Sure, yeah. Let me get you my business card.
So we'll take a question from this side.
Sure. So the game that Khurram showed, I believe, was built using Lewis. So I was wondering about the dialogue flow that was there, because I'm trying to build a bot with Lewis too. But the problem I'm facing is once I go down one track, I can't come out. So
That'd be good because.
for Lewis, that doesn't need to be I can hang out after this session because I think it's.
Yes, do hang out because actually the code is available, I think, for trivia. So we can get details on that. So you can just follow that as an example. Yeah.
Just one more quick question. You talked about voice recognition, right? Based on my voice.
Yeah. Speaker recognition. Yeah.
What if I have a cold or a cough and my voice has changed?
If the audio is drastically changed, then yes, the profiling that we do would be based on the audio that you provide. I mean, the idea is that you provide a very short piece of audio, so I guess that would be the audio where you don't have the cough, right? If your voice is drastically changes, then it will affect what the recognition is.
Okay. All right. Thank you.
Building on the previous question, about the language.
Just a bit louder so that I can hear.
Sure. Building on the previous question about the language, Portuguese, you were talking about the roadmap. Is Portuguese, native Portuguese, European Portuguese in the roadmap? Yeah?
Yeah.
Okay. Yeah, in the speech, now in
not
the
in custom
models.
No, not yet in custom.
But is it in the roadmap? That's what I was asking.
It is in the roadmap to go and support more European languages, yes.
Oh, okay. But No, in Lewis is only the Brazilian one. But to be honest, for accuracy, because it's not text-to-speech, it's just intense. It works really well because the grammar is very similar between the two languages. But the question that I really wanted to ask is, imagine, for instance, in Portuguese, if I wanted to build a model that would be really comprehensive in a given context, scientific context, for instance, there's a lot of English words that you would put into the custom model that you would need to understand. So today, you support multiple languages already. So I was asking, for instance, if you would do this in German, how would you build the model? Would it react well to mixed languages?
So maybe I can take this one. Yeah, that's a great question. I'm actually a native Portuguese speaker. I'm from Brazil. Okay. So it's a good example. So basically, if you add those, let's say, foreign language terms to your language model, what's going to happen is that the pronunciation that we generate for those automatically will match the pronunciation rules of the primary language.
Okay, so I need to say things, English words in Portuguese?
Yeah, but there is a workaround for that, which is the custom pronunciation feature that Panos described.
Oh, okay.
So basically, in addition to adding the material to the language model, we're always going to generate some pronunciation, and we default to the language, to the primary language, because that's the only thing we know about. Yeah. But then you can create a custom pronunciation, and then you can define, okay, this specific term, that's how it should be pronounced. And then the custom switch service is going to recognize that. So that's the way.
Would it recognize both of them? Like,
yes.
If I'm a good English speaker, I would say that in English.
Yeah. Remember the example of the Plougastel that I struggle to pronounce? Actually, it's a French name. And if any French speakers, Plougastel or something like that. Okay. So I had some trouble in getting it because it got generated automatically. But if I had used custom pronunciation, then I could get the way that I would expect people to pronounce, define it there.
Okay, thank you. Thank you so much.
Thanks. Let's get on this side. Yeah.
So you basically showed the sample which was using the speech API, client API, with the direct line, bot direct line. So can we use that in Xamarin and Android apps?
I just got the question about. Can you make the mic louder or? Sorry.
Yeah. Can you hear me now?
Yes, much better now.
So I was asking, like, you showed the sample with speech client SDK, right? And it was using the direct bot channel. So can we use that in Xamarin and Android apps?
Can they use that in,
Xamarin?
In Xamarin.
Oh, Xamarin.
Yes.
Xamarin.
And the native Android apps. Because Windows Universal apps, it's not well acceptable, right now. Not much.
So.
Right, but the SDK, if it's not available, it will be.
SDK will be available soon. We've just started with JavaScript, and we plan to support Xamarin, Python, and a few other languages based on user requests.
Okay. Any timelines for us?
I can't comment right now, but from what I hear from the developers, the protocol is a great starting point for you to write something on your own. For example, to write something in Python, we had a fellow developer do it in like 2 days.
Thank you.
So can we run this offline, like for the games, right? Anything offline not connected to the network? If we have some latency issue, if we want to use a mixed reality usage, let's take, which we have 8 millisecond threshold.
So you want to run the entire thing offline?
Yes.
The actual decoding?
Yeah. Let's take this game, right? It's a good game, but if I'm on plane, I cannot play this game.
So the models are deployed in the cloud, so you need connectivity to be there.
So there is a speech API in Windows.
Lewis.
Lewis? No. Lewis, no. Lewis, no.
Okay.
So there is a local only speech API in Windows that you can use, but it's not using the service.
Yes.
Yeah. So
actually, the speech API in the operating system does use the speech service, but it doesn't take advantage of the customization capabilities that it provides.
Okay.
Can I ask a question?
Yes.
This mic, like, you probably don't need the mic.
Actually, we don't need the mics anymore. Yeah.
So I wonder, how did you, for example, the 2 languages that you claim that you do very well, like English and Chinese, what content did you use to train your system?
So basically, the base models for conversational workloads were trained with Skype data, so basically recordings of phone calls, of Skype calls, YouTube videos, a lot of material where there is somebody speaking for a long time. Yeah, and then the Cortana data was trained on command and control scenarios, like, hey Cortana, what time is it? Hey Cortana, what's the weather like today? That kind of data.
Got it. So if like out of box without customization, if I read like someone without accent read newspaper,
yeah,
what is accuracy?
So that's a great question. So we tend to say that human accuracy, so a professional transcriber can get between 5 and 6% word error rate. So that's kind of the gold standard. So if you do better than that, you are doing better than a human, which is not the case yet today. So with the base models, without any adaptation, if you get a native speaker on a general purpose topic, I'll be confident to say that it goes between 10 and 15% for a native speaker, right? On non-technical vocabulary. Now, if you get somebody with accent, and we have a very interesting example in our organization. So our technical fellow has a Chinese accent. So he's a Chinese person speaking English. So his accuracy on the base models is very, very bad. It goes up to the 40% word error rate. Then by using custom speech services with a couple of hours of adaptation data, we're able to bring his accuracy to below 10%, or word error rate, so basically more than 90%
so
accuracy.
Default is what, like 15, is that?
It's not the default. I mean, if you fit in that category of person who has a native speaker, it would be around 15%, yeah. But we are, as Pano said, we're always working on new base models. So that's the data of today. It might be that next month we have a new base model for a given language and the word error rate goes down. So we're constantly training the models. So that always improving, always improving.
Is there any way that as I speak, like as my user speaks, I just feed the past, like the past sentences or whatever? Yeah, like as we speak. Do you support that model?
So you want to be able to adapt as you speak?
Yeah, no, not really. Like if I read off a newspaper where the text is known.
Mm-hmm. You're asking if you supply a grammar, can the recognizer do a better job?
Yeah.
Or if it's even possible to supply it. So
right, can I give you the text?
Yeah, that's what in custom speech service you can give the text, yeah. Yeah. And then we use the text to generate a language model.
So
if your scenario is one where you know the grammar ahead of time, and you're also okay with using the on-device capabilities, and you're on a Windows device, those scenarios are supported from a grammar standpoint. But it's much harder to program to know what the grammars are, what the CRIS service has done, and what the backend has done. You don't have to do that work. But if you are trying to optimize heavily, and you're in an environment that you might be able to use the Windows capabilities, it bridges both of them. You can do that. All right, thank you.
Is there any way when
the mic, please, for the other folks in the room.
Does it in LUIS, when some conversation comes, you have all the recorded the text that came into the service, so you can see what happened with that one. Do you have a similar one for the voice? When somebody is speaking to it, what are the utterances they say in the voice, so that when we go back and train the LUIS model according to what they are speaking, so that we can understand how the customers are trying to interact with our systems. Do you have something like that?
So your scenario is that you want to take the transcriptions and use the transcriptions.
Voice, actual voice, what they are speaking.
Yes. Well, the transcriptions, right? Because LUIS takes as input text.
Yeah.
Right, so you want to take the transcriptions and use this for LUIS to train a LUIS model, basically.
Yeah, kind of to train the LUIS model, also train the model, basically, what intent they are trying to say. Maybe there could be a different way than what we train the LUIS.
Right. So we're definitely working very hard in trying to improve the training experience across all the service. So that's likely a very good possibility that something like that's going to happen. Yeah. It's not available yet. It's not there today. So today the training experiences are decoupled, but we're working hard to bring them together.
That will help us in the custom speech.
Yeah.
We don't know all the
Yep.
utterances
Yeah.
they say.
You would still need the labels, though, right, for Lewis? I mean, you can get a transcription, but you still need to label each one of the utterances so that you know what the intent, mark what the intent is and the entities and so on. Okay, so we're going to close the session now. Okay, so thank you guys very much. We're still gonna hang around here, so if you have any more questions, you can come and see us.